For this lesson, we're going to quickly start with a warm-up to practice some organized counting and get back into the swing of that before we directly start permutations. So to start, a data management class has developed a survey which has 9 questions, and 2 of these questions are loaded questions. So how many ways can the questions be arranged? So for all of the questions, there's 9 total. How many ways, if we shuffled it up, could we arrange these 9 questions? So let's start by adding some spaces for all our questions. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, for our first question spot, we have 9 choices. I could have chose any of the questions, so there's 9 options. Then, for the second spot, I've already used up 1 question, so there's 8 questions to choose from. Then there'd be 7 questions, 6 questions, 5 questions, 4, 3, 2, 1. And because on the survey I have question 1 and question 2 and question 3 and question 4, I am going to multiply them. And 9 times 8 times 7 times 6 all the way down to 1 is the same as 9 factorial. And if I put that in my calculator, I'm going to get 362,880 ways as our final answer. For question B, it says, if the 2 loaded questions must come one after the other, how many possible arrangements are there for the survey? So now let's space out our questions again. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm just going to put my 2 questions together at the front here for right now. So I have question 1 is a loaded question, then question 2 is a loaded question. So by the time I get to question 3, I've used up 2 of the questions, so I only have 7 choices left. Then I'd have 6 choices left. 5, 4, 3, 2, 1. Now, this L1 and L2 combo doesn't have to be in that first spot. This L1, L2 combo could be here, that's the first spot, or here, that's the second spot. It could also be here, which is a third spot, here, which is a fourth spot, here, which is a fifth spot, sixth, seventh, and 8. So, in addition to this multiplication, we also need to multiply by 8. And then we could have L1, L2, but we could also have L2, L1. So that doubles all of our options because we could have L1, L2 or L2, L1. So all of that is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 8 factorial, and then we multiply that by 2. So that whole thing will give us 80,640 ways. So for question C, it asks us, if the 2 loaded questions are to be separated by at least one other question, how many arrangements are there for the survey? So this is just asking us how many ways are there for L1 and L2 to not be together. In other words, the opposite scenario of question B. So to find that, we can take our total options and minus our undesirable. So that would give me 362,880 minus 80,640, which would leave 282,240 ways. So now let's go through another example. A teacher has a bank of 38 questions for a particular test. 10 questions are to be chosen randomly from the question bank. How many different tests could be made? So let's write out our blanks for each question. So there's 10 questions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now she's pulling from a bank of 38 questions. So for question 1, she could choose any of those 38 questions. So we'll do 38. Then she's used up one of them, so there's 37 left for the next one. Then 36, then 35, then 34, 33, 32, 31, 30, 29. Again, because she is having all the test questions, so she'd have question 1 and question 2 and question 3. So because I'm using the word and, I multiply everything together like this. And when I put that on my calculator, you're going to get a big number, which is 1.72 times 10 to the 15. So as you can imagine, there are so many different tests if these were all generated randomly, and it would be very unlikely that the person sitting beside you would have the same test. So these style of questions is what our lesson is really getting towards. So that brings us right to permutations. And a permutation is when an arrangement is made in a definite order. So in other words, our order matters. The order of those questions makes it different than a different order, right? If I had question 1 and 2 swapped, that would be a totally different situation when we're talking about permutations. So the total number of possible arrangements can be computed using this formula, n permute r. So this little thing here, we would call that n permute r. And n is my number of distinct items, and r is the number of places in the arrangement. So if we were to do this by hand, here is our equation. There is a button on your calculator for this. Depending on the calculator you have, sometimes it's easy to find, sometimes it's hard to find. But if you Google your calculator, like the name on the top and permutations, there's usually a video that shows you how to find it. So let's try to use this in an example. So for our example, there are 10 students to choose from, and there are 3 chairs. How many ways are there to arrange the 3 chairs with 10, to arrange the 10 people into the 3 chairs? So let's start by using the fundamental multiplicative counting principle. So basically kind of doing it by hand instead of using the formula. So we'll start by drawing our 3 chairs, chair 1, chair 2, chair 3, and there are 10 students total. So for my first chair, I could choose any one of the 10 students. Then for the second chair, one of those students was already chosen, so I could choose 9. Then for the third chair, 2 of the students were already chosen, so I'd only have 8 more options. Because I have chair 1 and chair 2 and chair 3, I multiply all of these. And if I put all of that on my calculator, I'll have 720. Now, what we can do is we can try to do this using our permutations formula. So, our n value here is going to equal 10 because there are 10 students, and our r is going to equal 3 because there are 3 chairs. So we're going to write 10 permute 3, which will give us 10 factorial all over 10 minus 3 factorial, and 10 minus 3 is 7, so we will get 10 factorial all over 7 factorial, and if you expand that to simplify it out, we'll have 10 times 9 times 8 times 7 factorial all over 7 factorial. So now you can see how this matches our example above, and then we will get 720 ways again. So that's a good way for you to see how this works, doing it by hand with our box technique or by using the whole formula. Now, sometimes having the visual really helps, but if we have really, really big numbers, using the equation makes things much more efficient. Okay, let's try a few more examples. So for our next example, a brand new high school math council is being formed. 7 people from data management class A have volunteered, and 6 people from another data management class, class B, have also volunteered to join. The math council is to have an executive that includes the position of president, vice president, secretary, treasurer, and our spirit coordinator. So let's start by identifying how many different executives can be made from the volunteers of both data management classes. So first, we need to find our total number of people. So we have 7 people in class A and 6 people in class B, so that means 13 people total. Now we have 5 positions. So we have 1, 2, 3, 4, 5 positions that are comprised of our president, our vice president, our secretary, our treasurer, and our spirit coordinator. So for president, I would have 13 choices. Then I've used up a choice, so I have 12 for VP, then 11, then 10, then 9. Again, because I have a president and a vice president and a secretary, I multiply, and then I would get 154,440. Now I could have also used my permutation formula. So I had 10 people, 5 roles, and if I put that in my calculator, I get the same thing, or if I did the formula by hand. So now let's add a couple more layers to this. So how many different executives can be made if the president and secretary must come from class A and the other positions must come from class B? So let's start by drawing a diagram. So our president and our secretary must come from class A, and then our vice president, our treasurer, and our spirit coordinator must come from class B. So again, class A has 7 people. So for that first position, there are 7 options. Then for the second one, there are 6 options. Similarly, for class B, they have 6 people. So for the first spot, they have 6 options, then 5, then 4. So now let's put together our permutation formula for each of these situations. So for class A, we had 7 people with 2 spots. And then for class B, we had 6 people with 3 spots. Now I multiply these together because I need the people from class A, I need those 2 positions, and I need the other 3 positions. So because I use the word and, I'm multiplying. So you put that in your calculator, you are going to get 5,040. All right, one last example. So how many different executives can be made if the president must come from class A, while the vice president and secretary come from class B, and the other positions can be filled by anybody? So let's draw out our seats again. So we have our president's seat, and that must come from class A. Then we have our vice president and our secretary seats, which must come from class B. And then our last ones, it doesn't matter who they're filled by. So for class A, that president spot, there were 7 people in class A, so there are 7 people who could take that spot. So in other words, 7 people, choose one of them. Then for class B, I had 6 people, and so I have 6 people for the first one, 5 for the second spot, so I have 6 people and 2 spots. Then for the last one, I need to think of how many people I have left. So I originally had 13 people. I used up 1 for president, used up another for VP, and used up a third for the secretary. So I only have 10 people left. Then I would only have 9 left to choose from. So I had 10 people and 2 spots. So I multiply all of those together and I will get 18,900 as our final answer.